The intermediate value theorem. So let f be a function that is continuous. It has to be continuous. That's a key thing. The whole function doesn't have to be continuous, but it needs to be continuous on a closed interval. So in some restricted domain. All right? Closed interval means equal to. So there has to be a function that's continuous in a closed interval where f of a does not equal f of b. So when I fill in a value for x for a, and then I fill in a value of x that's b, they're not the same y value. Okay? One could be 1, one could be 2. It's not a horizontal line. Yeah. If n is any number between f of a and f of b, then there is at least one, not on, there is at least one number c. Typo. One number c in that open interval a, b, for which f of c is equal to n. So basically, that is a very long, convoluted way of saying, if I plug in a and I plug in b and I get two y values, say one of them is 1 and one of them is 18, and the graph is guaranteed to be continuous, every y value between 1 and 18 will exist, technically, correct? So if I had a y value that was -7 and I had a y value that was 30 and the graph is supposedly continuous between those y values, it could do this all at once. It means that between -7 and 30, every y value that exists between that will exist. Correct? That's just knowledge. Like, that's what the intermediate value theorem states, but that's just general knowledge. If I have a continuous function from -7 to 30, every y value exists between -7 and 30 because it's continuous. So it could look like that. It could be a direct line. Correct? But every y value between -7 and 30 exists. That's what it's saying. Okay? So this one says, use the intermediate value theorem to show that f of x equals x cubed plus x squared minus x minus 2 has a 0 between 1 and 2. This is not a hard thing to show. A 0 is just an x-intercept, correct? What's the y value of an x-intercept? 0. So I need to show that this graph, x cubed plus x squared minus x minus 2, has an x-intercept, y equals 0, between 1 and 2. It's not a hard concept, but people don't get full marks because they don't prove the intermediate value theorem. They just show some work. So in order to prove the intermediate value theorem, you have to find the y value when x is 1 and the y value when x is 2. We agree? And if the y value when x is 1 and the y value when x is 2, 1 is below the x-axis and 1 is above the x-axis, then there's for sure an x-intercept, correct? What everyone forgets to do is they forget to explain that this graph is continuous. If you don't explain that this graph is continuous, and you show a y value below and you show a y value above the x-axis, and then you say, and therefore, there's a 0. If you don't say that that graph is continuous, therefore there might not be a 0, right? There could be an asymptote in between those. That means that there is no x-intercept. So intermediate value theorem, yes, you have to show f of 1. Find out what that is. Yes, you have to show f of 2. Most people do this. But what people forget to do is they forget to say, hey, f of x is a cubic function. It's a polynomial. And all polynomial functions are continuous, right? So this graph is continuous. You have to state continuity in the intermediate value theorem. Or you can't just say, oh, I have a value below, I have a value above, therefore there's an x-intercept. You can't do that unless the graph is actually continuous, correct? So everyone forgets to state continuity. So I'm going to put this here. In order to prove the intermediate value theorem, remember, you have to state continuity somehow. So we need to find our values first. Let's find f of 1. So it's just direct substitution. We have 1 cubed plus 1 squared minus 1 minus 2. So we get 1 minus 2, which is -1. So in order for this to work, f of 2 is going to have to be bigger than 0, correct? Because I already have one that's less than it. So if f of 2 was like -7, there would be no guarantee. Could it possibly, though? Let's think about it. If f of 1 was -1, and f of 2 was negative 16, people will tell me, no, there's no possible way. Well, there is, because if the graph went like this and came back down, there is a possible way. But is there a guaranteed x-intercept in there? No. So then the intermediate value theorem is saying show that it has a 0, not that it possibly has a 0. Okay? So if I know that one of these, this one is negative 1, I know this one's going to have to be positive somehow, so let's plug it in. Other than that, if it's not positive, we can't guarantee. There could be an x-intercept, but there's no guarantee with the intermediate value theorem that there is. So we're going to get 8 plus 4 minus 4 is 8. So now people will say, therefore, there's a 0 between 1 and 2, because f of 1 is negative 1 and f of 2 is 8. What are we missing? That it's continuous, right? So we have to say f of x is a polynomial function, or a cubic function, whatever you want to say. Which is continuous. Since f of 1 equals negative 1, which is below the x-axis, and f of 2 equals 8, which is above, the x-axis, and the graph, we're going to really and this, we're going to do some really big old run-on sentence, and the graph is continuous, there exists a 0 between 1 and 2. So just stating that f of 1 is below and f of 2 is above is not enough, correct? Because I could have a value below and a value above and not have them connected, and then there maybe isn't a 0, correct? So you have to say there is a value of y below, there's a value of y above, and the graph is continuous, so therefore there's a 0. You have to do 3 things for the intermediate value theorem. Find f of the one value, find f of the other value, state that the equation is continuous, and then give yourself a sentence. The sentence can suck, but the sentence at bare minimum has to say that f of whatever this is above the x-axis, f of whatever this is below the x-axis, the graph is continuous, therefore it has to pass through the x-axis. There is a 0, something like that. Sometimes they don't ask if there's a 0, sometimes they ask if there's a value 6. Well, then you have to find a value below 6, find a value above 6, say the graph is continuous, and therefore it would go through the line y equals 6, right? It doesn't have to be a 0, it could be other things. Try this. Tomorrow we do trig. The thing that's not going to be on this unit exam is squeeze theorem. So squeeze theorem is in calculus and it's in AP calculus, but I'm only teaching it after because I confused everyone. So that's for it.